So welcome back guys, this is Madhav PVL, and in this video we are going to discuss about different system calls or different system calls in this operating system which deals with the process management. So we'll just discuss one by one. So before that, what API? So what is API? API is application programming interface. That is nothing but a group of functions to write the user programs. So what API does OS provide to user? So API provides a set of system calls. So system calls are nothing but it's just like a function, a bit of code. A bit of code is a system call. So this application programming interface will just provide a set of system calls. A system call is a function call to operating system code that runs at higher privilege. So here we can just say like some particular works will be done repeatedly, right? So to avoid that repeated work, if we need to just say something like if we are just going in a particular journey, so if you are just going in the journey for the first time, then we will just be careful about the routes. But if you are just familiar with that particular route, then next time that won't be much difficult. So this is nothing but if that particular code is already written, then we will just save that code as a function. So system call is a function call to operating system code that runs at a high privilege. High privilege is nothing but sensitive operations are allowed only at a higher level. Sensitive operations are nothing but access to the hard drives and all those things are the sensitive operations. So the code which is written in this high privilege will only have the access for this sensitive operations. Should we rewrite the programs for each operating system? No, that is not the thing here. So POSIX API, application programming interface, POSIX application programming interface. So this is a thing which is having a standard set of a system calls that an OS must be implemented. So OS must require this basic system calls in its operating system. So POSIX API is nothing but a standard set of system calls that an OS must implement. So programs in POSIX API can run on any POSIX complaint OS. So if this particular operating system is containing this POSIX API, then the programs in that POSIX API can be run in that particular operating system. Almost every modern operating systems are containing this POSIX API. So program language libraries hide the details of invoking system calls. So this is one of the thing. So programming language libraries hide the details of invoking system call. A printf function in a C library calls the write system call to write to the screen. So invoking the system call in the sense, so if we just write the printf, it will not show the whole code which is regarding that particular write system call. So it will just directly use this printf and it will just print the details which are required, but it will not just show the whole write thing to the user. So the program language library hides the details of invoking a particular system call. So the printf function in a C library will just write something on a screen, but it will not show that whole write code, right? So it is not required for this user. So user doesn't require the whole write code. So it will just invoke in that particular system call. Printf function in a C library will just call the system call to write on the screen. So process related system calls in UNIX. So fork is one of the most famous system calls which we might have heard about this. So fork creates a new child process. Fork is nothing but it is just for the purpose of creating new child processes. All processes are created by forking from a parent. So basically there will be a particular parent initially. So by applying that fork command, that parent process will just generate some children, so one child. So init process is an ancestor of all the processes. So before starting on particular operating system, there will be something which is init. So init process is an ancestor for all the processes. So init will be executed first and it will just create some processes, and with the help of those processes fork command will be called, after the fork command is called, then it will just create some child processes. So init process is an ancestor of all the processes. So execc makes a process execute a given executable code. So execc makes a process execute a given executable. So exit terminates a process. If the process is completed, then it need to just get terminated, right? So the termination will be done with the help of this exit function. So wait causes a parent to block until the child gets terminated. So if the child process is completed, then wait causes a parent to block until the child gets terminated. The child gets terminated in the sense, if the process is completed, then the child should be removed from that particular thing. So many variant exist on the above system calls with the different arguments. So we will just discuss in the upcoming videos. So what happens during fork? So during fork, this is a parent, the parent will have some particular code. In that particular code, it will have something like fork. So if the fork will just create a copy of that particular parent, and it will just name it as a child. So the child will also have the same code which it is having in that particular parent. But the child may change the code, so we will just discuss it one by one in the next system call. So new process is created as a copy of a parent's memory image. So as a copy of a parent, the child is created. So new process is added to the particular OS processed list. So the parent and the child starts work after the fork command gets executed. So after the fork commands gets executed, this both will again start their working on that particular process. Parent change can modify the memory data independently. So the memory and the data can be changed independently in this both parent and child. So sample code for fork. So fork, now let us just see step by step. So printf hello world, PID is nothing but the process ID, get the process ID. As this is an integer, it is printing as a %d. So int rc is equal to fork. Rc is nothing but the index or the number which is given by the fork. So if rc is less than 0, so if the fork index is less than 0, then the fork is failed. So if less than 0, then the fork is failed. So less than 0, the fork is failed. Then exit 1, so it will just get terminated from that particular program. If rc is double equal to 0, then here we can just say like I am the child. So the child is created, in the child will have some particular process ID. So we will just print that particular process ID here. %t get process ID. Else if print I am the parent of that particular child. So rc will just print the index of that particular fork, that is it will just print the index of the child, and then it will just give the process ID at that particular instant. So I am a parent of a fork, that is rc %d, and then let me just be clear. Here the %d refers to the rc, here the rc refers to the fork, whereas this PID %d will just represent this get PID at that particular instant, and it will just return the 0. So this is a very basic sample code for the purpose of fork. So waiting for the child to die. So what is this? Actually this title will just this title is something which is mysterious, so don't panic. So this title states is like process termination scenarios. So this will be learnt in this particular concept, process termination scenarios. Generally a process will just get terminated in two ways, like by calling the exit. So if we just call the exit, then the process gets terminated. Otherwise the second scenario is OS terminates the process if it is misbehaving in the sense if it provides any errors, or if it is having any interrupts or whatever it may be. So OS will just terminate that particular process. Misbehaving in the sense just providing some errors or whatever it may be, something which is not natural. So if that process is behaving something which is not natural, artificial way, then that is misbehaving. So terminated process exists as a zombie. So here we can just see in some ghost movies, so if a person dies, he will just be like a ghost. So here the ghost is nothing but a zombie. So what will the zombie do? So zombie will just consume memory resources without any proper reason. So zombie will just consume memory and resources without any particular reason. So it doesn't have any particular reason, which may create some loss. So when a parent calls a wait, zombie child should be reaped or cleaned up. So zombie should be cleaned up. This can be done only with the help of a particular parent call. So only a parent can just reap or clean up that particular zombie. So no other one can just because the zombie is nothing but its own child. So the child will just listen to this particular parent, right? So parent need to just clean up or reap that particular zombie to just avoid this whole thing. So to call to just reap or clean up the zombie, we need to just use this wait function. So if we just use this particular wait function, then the parent will just wait for some time and it will just reap or clean up that particular zombie. So wait blocks in parent until the child terminates, that is the child, until the child gets reaped. Until the child gets reaped, the wait will just block in the parent block. So what if the parent terminates before child? So if the parent's process is just completed, here if the parent process is completed, then if this gets terminated, then here also we are having some another alternative. So that is what if the parent terminates before child? So init process adopts the orphan and reaps them. So init will just adopts that orphans and then reaps them. So init is a process which will be available at every time. It will just adopts those orphan processes and reaps them. So every terminated process should be reaped, otherwise it will just consume the memory resources without any proper reason. So what happens during exec? So here we had just discussed it. If we just apply this fork command, then the parent will just create a particular child. So child will also have the code which is same as the parent. So what is the help of this? What happens during exec? So if after fork parent and child codes are equal, so these both codes are equal, a process can run exec to load another executable to its memory image. So if we need to just change this particular code in this child, so if you need to just change the code in this particular child, then we can just run this exec to load another executable to its memory image. Child can run another program, so another program can be run in that particular child if we just use this exec. So how does a shell work? So what is shell? Shell is nothing but one of the basic thing which is created, which we can just say like DOS shell, BIOS shell. Basically if once if the OS is started, then there should be some basic things which are required for some basic operations. So to start a particular operating system, there should be some basic operations to execute a basic system calls. This shells should work. In a basic operating system, init process is created after initialization of a hardware. So initialization of a hardware is nothing but after starting the operating system, the initializing of the hardware will be completed and then a shell will be created. The init process spans a shell like bash shell. So if the initialization of a hardware is completed, then a shell is created which is named as a bash. So shell can perform all these operations. So shell reads the commands and then forks a child. Forks a child is nothing but creating another child, and then exec is the command, executes the command, and then wait for the finishing of the command, and then reads the next command. So all these things will be done with the help of this shell. So simple commands like ls are the part of this shell. So after getting into that particular putty, so if we just get into the putty or something which is related to this operating system, Linux XP6 operating system. So if we just press the ls, so it will just present the list. So that is a part of this particular shell. So simple commands will be a part of this shell. Other things which are done by the shell are, shell can manipulate the child process. So to redirect the output from the command to file prompt ls, so here to redirect the output from the command to a file, so it is just redirecting the output from a command to a file. So if we just click the printf, then it will just give the output on that particular screen. So but now with the help of this shell, we are just transferring it to the output to that particular file. So we need to just get that output in a particular file, which is foo.txt. So shell spans a child, rewrites its standards output, then calls exec on the child. So these are the things which were also done with the help of this shell. So this is all about a basic system calls for the purpose of executing some basic standard set of programs in that operating system. So thank you for watching.